All right, guys, look. This this one right here, that triangle. I tried to make a video earlier. That video right there is an ass triangle. I don't like ass triangles because they mean that we have the ambiguous case and they are an impossible amount of work for us to do. That's not actually true. They're not hard for us to do, but to do this on a final would be kind of excessive. So what I did is I want you to go in here and I want you to cross off the thing that you have created there that was here. Write this one, and that is what we're going to be doing. Now, we're going to be doing law of sines and law of cosines for these problems. Somebody asked in class, when do you use law of sines versus law of cosines? If they give you two angles, you use law of sines. If they give you one angle, use law of cosines, full stop. Doesn't matter what else is going on. We're not going to run into an ass triangle, so you're not going to have to worry about that. That's what you're going to do, because if I have all three angles and I know what they are, there is no ambiguity about finding the other values. However, please make sure when you're in this situation, you put your calculator in degrees. Because if it is in anything but, you're screwed. Okay? Now, that being said, let's do it. First one, I got two angles. I'm using law of sines. Law of sines is that the sine of alpha over A is equal to the sine of beta over B is equal to the sine of gamma over C. So we're basically creating values that is going to work with something like that. Okay. So with that being said, this is what I got to do. I got this triangle right here. I have a pairing here with the 20 and the 4. So I can start off by saying that the sine of 20 degrees over 4 is equal to, now, I don't have side C here, so let's use the 60. I can say the sine of 60 degrees over C. All right, that being said, I can completely use this to find our value. So if I'm going to do this, let's cross multiply right here. This is going to be C times the sine of 20 is equal to 4 times the sine of 60. And then because I'm solving this for C, I will take both sides and I will divide it by the sine of 20 degrees. That'll cancel out, and I get that C is equal to 4 times the sine of 60 over the sine of 20. Now, I have got to pull out my calculator to figure this out, which I had forgotten to do before this, but, all math teachers have one close. So here we go. Actually, all people have one close because you've got your phones, but I didn't want to do it on there. So I'm going to go 4 times the sine of 60 degrees, and I'm going to divide that by the sine of 20 degrees, and I'm going to get that C is equal to 10.13. Okay, so I found the C value that is right up at the top here. I now need to find beta, and I need to find B. Okay, so the beta part should be totally easy. And normally it's what I would start with, but I got all caught up in the awesomeness of all of this. I have two angles and I need a third. The reason why it's okay when they give you two angles is because process of elimination tells you what you have to have. Our beta is going to equal 180 minus the other two angles put together. So with that being the case, this will be 180 minus 80, which is going to give me a total of 100 degrees. So that angle beta up there will be 100, and I know that you can figure that out. So now I'm going to use that to find my B value. So I'm still going to use the pair that they gave me, the 20 and the 4, because I rounded that 10.13. And I'm going to say that the sine of 20 degrees over 4 is going to equal the sine of 100 degrees over B. Now, I don't love using the letter B for something like this because it sometimes looks like a 6, but you get the general idea. So we cross multiply. We're going to get 4 sine 100 is going to equal B times the sine of 20. And then I'm going to divide both sides by the sine of 20. And I'm going to get what my B is equal to. All right, so in this case, B is going to equal, okay, again, use our handy dandy calculator here. 4 times the sine of 100 divided by the sine of 20. I get that B is equal to 11.52. Okay, so we've got all the values that we're going to need for something like this. We have B is 11.52. we have C is 10.13, and we have angle beta is 100 degrees. Okay, so you have everything that you're going to need for a law of sines problem. When we go into a problem like 2, anytime they give you one angle, we are dealing with a law of cosines. Sometimes they might give you no angles, and we'd have to go backwards to find it. Also fine, but because we're working with this in a little bit of a different way, I'm going to use the side angle side one for us to look at. Now, what we have to remember with this one, there are 3 versions of this, and it's going to be given to you on the final, but ultimately what you're going to do is this. I don't have these opposite sides done, so I'm going to call this across the way here is a lowercase b, because I don't know what that is. There is C here, so the opposite angle here is going to be gamma. And over here, the opposite angle is going to be alpha, because those are the things that I have. Now, our formula that we're going to use to start is going to be the one that relates these two, the angle that you have and the opposite side that you do not have. So we're going to say that b squared is going to equal a squared plus c squared minus 2ac cosine of angle beta. So I'm going to plug all the stuff in that I can. I do not know in this case what the b is. So that is going to stay our unknown value, the b squared. A squared is the one opposite the alpha, so that is going to be 15 squared plus 19 squared minus 2 times 15 times 19 times the cosine of, in this case, beta is 120 degrees. Calculator is going to do a whole lot of work for us, and that's fine. B squared is going to equal, all right, let's do some math. 15 squared, I think it's 225. Yep. 19 squared is 361. Minus, okay, 19 times 15 times 2 is 570 cosine of 120. I'll start to combine some things because eventually I'm going to have to take the square root of all of it. So 225 plus 361, that's 586 minus 570 cosine of 120. Okay. So here's what I'm going to do. Right now, cosine of 120 is on the unit circle, and it's fine that that's on the unit circle. You are going to get negative a half for this one. Trust me, plugging it into your calculator is going to make life a lot easier because you're going to have to take the square root of it, but it's nice to kind of know that that's the case because it does mean that we're going to have a negative and a negative here. So b squared is going to equal 586 minus 570 times negative 1/2. Okay, 586 minus 570 times negative 5. I'm going to get that b squared is equal to 871. Square root both sides, and you're going to get that b is equal to whatever the hell the square root of 871 is. I certainly don't know, but I'm excited to find out what we get. Oh, it's because I hit the wrong button. Sorry. 29.5127. Okay, so we're going to say that b is equal to 29.51. Okay, so we have our b. Great. All the better. Now, I've got to use what I have here to then find either alpha or gamma. It doesn't matter which one you want to use because you're going to have to use the 3 sides regardless. So let's use, for funsies, alpha because it's up here. So knowing that, the formula that we're going to use is going to be the a squared. So it's going to be, well, hold on. It is going to be lowercase a squared is equal to b squared plus c squared minus 2bc cosine of alpha. We don't know alpha in this case, but we do know all of the other values. Okay, so we're going to start to plug them in here. 19 is our lowercase a, so this will be 19 squared is equal to b squared. Now, we just got that was 29.51. Plus 15 squared, because that's c, minus 2 times 29.51 times 15 times the cosine of alpha. Okay, I'm going to solve this for alpha. And I need you to watch these steps because when we find a value for that, I have seen some mistakes that have been made. And they're not mistakes that I'm going to be like, oh, of course, this is going to be an easy thing. They're pretty straightforward. So let's just make sure we're kind of on the same page. 19 squared is 361. 29.51 squared is 870.8401. Now, I know I rounded that because it was actually the square root of 871, but I'm using that, so let's just keep using it. Plus 225 minus 2 times 29.51 times 15 is going to give me 885.3 cosine of alpha. Okay, guys, when we're doing this, we're going to get that cosine of alpha by itself, right? So first thing I got to do is put those two together. So 361 is going to equal 870 point 1095.8401 minus 885.3 cosine alpha. Now, I did say some people make the mistake where to solve this, they combined the two of those first and then divided it to the other side. We have to remember is that that is a coefficient for my cosine. So I am going to have to first subtract this constant that's out here. And again, this is messy math, but it should still work. So we do 361. Give me a second. And if I put those together, I'm going to get negative 734.8401 is equal to negative 885.3 cosine of alpha. Now I divide both sides by negative 885.3. I know that the output for cosine goes between positive 1 and negative 1. So I'm hoping to get a decimal that's going to work here because these are pretty close to each other. This is definitely going to be less than 1 because this is a smaller number than this number when we divide by the absolute values. So it's helpful so that I don't worry about getting something that is not going to give me an answer, which is something I always worry about doing this. Divide that by negative 885.3, and I get 0.83 is essentially what I'm getting. To find the alpha, we are going to take the inverse cosine of both sides. On this side, they will cancel out. Now we'll get that angle alpha, and it's going to equal the inverse cosine of this. Now I'm using what I have in my calculator. So the inverse cosine of that is 33.89. So really a 33.9 is what we're going to have. Yeah, because it does that 6 rounds it up. So 33.9 degrees is our alpha. Okay, so right now, if I look at the triangle that we're looking at, we have 120, we have 33.9. To find the gamma, all we have to do is take 180 minus the sum of that 120 and that 33.9, and then we are going to get the final answer for this. 180 minus 20. We get that gamma is equal to 26.1 degrees. So those are the ones we have. If you had gone to solve for the other one, you'd get the same general idea as we work our way around. So that is how you use the law of cosines to find first the side that we needed, and then use that side to find the angle. And that's the way that we work through it for all of it. So there's all of our work. Again, if you need to rewind to be able to see any of this stuff and see what happened, that should be great. And that's what we need. So that is it for now. And I'm going to say one more.